Okay, so I am delighted to introduce our first keynote, Sarah Sharples, who will be speaking on why nurturing research ecosystems is critical to UK cybersecurity and to ensuring a safer and more prosperous place. Sarah Sharples is Chief Scientific Adviser for the Department for Transport and is a Professor of Human Factors in the Faculty of Engineering at the University of Nottingham. Sarah has led research in transport, manufacturing and healthcare and currently leads the EPSRC's Connected Everything Network Plus. She has founded and is co-director of the EPSRC Horizon Centre for Doctoral Training and has led research programmes examining implementation of new technologies in rail, highways and aviation. So Sarah, if I can ask you to please share your screen. Sarah has some slides. I have seen Sarah on the call, she is here.
Right, so hopefully that is working. I've pressed the share screen button, so you should be able to see the presentation.
Yes, it's just load. Yes, perfect. Thank you, Sarah.
Excellent. Do shout if anything goes wrong, as government laptops aren't very good with Zoom. So, as I say, just shout if anything goes wrong. Really lovely to see you all, and thank you very much for the opportunity to present to PETRAS. I've been a fan of PETRAS for a number of years, and I think one of the things that works really, really well with PETRAS is, first of all, that sort of socio-technical multidisciplinary approach, but also that real understanding of the needs of policymakers of how to communicate academic research. So what I'm going to talk about is a little bit about what it's like being a Chief Scientific Advisor in the Department for Transport, or more generally. Talk a little bit about what we do to support research and innovation within the department, and then talk about some of the cybersecurity issues that we are facing within a transport context as well, just to hopefully provide a little bit of framing for you. And I'll make sure there are time for questions as well. So, right, hold on. There we go. So hopefully the slides changed. I see some nodding. There should be a picture of a motley crew. Okay, brilliant. So this motley crew is a snapshot of my fellow Chief Scientific Advisors. One of the things that I think has probably been really raised in the profile since the COVID pandemic is the existence of Chief Scientific Advisors. And something that's really important is that we have an independent challenge role. So I'm appointed on secondment from the University of Nottingham. Different Chief Scientific Advisors are appointed in different ways. And my job is both to provide independent challenge to the Department for Transport, but also really act as a member of the Department for Transport and help them in how they develop their innovation and research and development activities, and really bring science, technology, engineering and innovation to the heart of all that they do. But one of the joys of being a Chief Scientific Advisor is working with my fellow Chief Scientific Advisors across government. And you can see some images of them here. Most of the government departments now have Chief Scientific Advisors, and we are all supported by the Government Chief Scientific Advisor, Sir Patrick Vallance. And so I think it's really important just to recognise that none of the work we do in individual departments is done in isolation of that wider government thinking. So not only have we got the sort of breadth of the work of the Chief Scientific Advisor across all of government, but the Department for Transport itself covers almost all eventualities. And transport's an enabler, and it provides us with access to jobs, it provides us with access to education. It's also an industry that delivers economic prosperity to the UK. And it's also something that is really, really changing very, very significantly. So my portfolio covers everything from considering the future energy requirements for our decarbonised transport systems of the future, understanding what technologies, infrastructure and systems we might need to enable active travel, thinking about freight, everything from sort of maritime, aviation, ports and logistics, what might be the opportunities for drones in freight deliveries, particularly last mile deliveries, for example, thinking about new electrification technologies, and then thinking about automation. how we're introducing connected and automated vehicles onto our roads, onto our railways, into our aviation and our maritime settings as well. So every day is different, which is great fun. But it also means that I'm definitely not the deep expert in absolutely everything that I need to deal with across the department. And in a way, my job is to be a portal to the expertise, some of which sits in organisations like PETRAS. So the way in which this works is that there are a number of specialist teams within the department. They might be the team that sits with me, the SciTech team that provides advice and guidance to all of the department on embedding science and technology. Might be, for example, understanding the implications of position navigation and timing systems within the department, for example. We've got a specialist national security science and research grouping, which commissions specific research to understand how we use technologies to make our transport systems secure and resilient. Look specifically at the opportunities around emerging technologies. If we think of technologies like artificial intelligence or quantum computing, there are implications for those technologies within the world of transport, and it's unrealistic to expect every transport organisation or every transport mode team to have deep expertise in those areas. So the emerging technology team holds that deep expertise and works in partnership with policies. We've got specialist engineers who provide specific advice on major infrastructure programs, looking at the opportunities to embed innovation and technologies in our future infrastructure development. And then we've got a really outstanding group of scientists who deliver social and behavioural science, both conducting ongoing social research, such as, for example, our technology tracker that can monitor the changing attitudes towards transport technologies over a period of time, but also understanding how we use behavioural science expertise to influence the way in which we design our transport systems now and in the future. We also engage with our arm's length bodies, so Network Rail, National Highways, Rail Safety and Standards Board, and other sort of groupings, Civil Aviation Authority, Office for Road and Rail, DVLA and DVSA. So there's lots of different activities there. And we work with our external partners through our Transport Research and Innovation Board. We work with our academic partners through our Science Advisory Council, that's a group of expert advisors. And then I chair our Research and Development Board that oversees the research that's funded from the department. Now, one of the things to remember is that government R&D is only a really, really small part of the picture. So if we think about R&D that's funded within the Department for Transport, and at the moment our budget for the 3-year spending review period is 577 million, so quite a lot, but nothing compared to, for example, the UKRI funding portfolio. We've got both a range of different sources of funding that come from government and different government departments, but we also know that to deliver the impact that we need from R&D in order to address what's known as the productivity challenge and other factors that we know demonstrate the sort of strength of the UK as a science superpower and our thriving knowledge economy, we also need to leverage funding from industry. And actually the ratio tends to be, depending on how you count it, either 1:3 or 1:4 in terms of the proportion of funding that you'll get from government. So for every pound from government, we need either 3 or 4 pounds to come from industry R&D. Now, this graph has been a graph that's been hovering around government for many years now. And it's interesting because it's changed recently. So you'll see at the moment that the UK is that yellow dot sort of in the middle of the graph, slightly above the line. What that shows is what's been known as the productivity puzzle, in that there's generally a linear relationship between the amount of research and development that's spent as a share of gross domestic product within a within a country, and a relationship between productivity measured by output per hours worked. And the UK always seemed to be a bit of an outlier. Its productivity seemed to be high compared to the amount of R&D that was funded. Now, any of you who read lots of tweets about R&D funding will know that recently that dot has moved significantly to the right of the graph through 2 changes in the way that the Office for National Statistics measures both the industry funding of R&D and the R&D funding that's spent within universities. I won't go into why it's moved from the middle of the graph to the right-hand side of the graph, but what that now means is that we are much closer to the line in terms of our relationship between productivity and R&D. But it also means we need to rethink some of the analysis that's taken place over the last few years in terms of understanding that relationship for R&D. But I think more broadly, when I'm talking about the value of R&D, the first value of R&D within government is it's answering the question. It's helping us understand which technologies we need to use to decarbonise heavy goods vehicles. It's helping us to understand what the different accuracy of different types of position navigation and timing might be, and how we can understand our vulnerabilities if any or all of them fail. So that's the sort of answering the question part of R&D. The second part is the work that we're doing stimulating economic prosperity? We want to make sure that the funding that comes from departments like the Department for Transport is providing the impetus and the signal to industry to take ideas through to development. And so an example of that might be our Centre for Connected and Autonomous Vehicles that's run jointly with the Department for Business, Energy and Industrial Strategy, BEIS. That's invested 300 million over recent years. It's directly leveraged industry funding of 400 million, and 35 of the companies that have engaged in that programme so far have secured 790 million in investment from venture capital. So that's one of the things that we really care about from a government funding point of view. And then the final thing is the place-based agenda. Both the government and sort of both recent administrations and the current administration have recommitted their commitment to levelling up. And what that means is making sure that we've got a concentration of funding that's broad across all 4 nations and broad across the regions within those nations as well. Now, something, and I did steal this slide from Patrick Vallance, so I thought it's always good to remember our history. And this principle that we talk about often called the Haldane principle. And this came from Richard Haldane, and there's a good Wikipedia page that I was revising earlier, actually, that tells you all about the history and in some cases the controversy around the Haldane principle. But it's a really important principle that holds, which is around the independence of decision making about which research projects to fund, and that this should be done through the principle of peer review, independent evaluation by experts based on the quality and likely impact of their research. It's interesting, we maybe think consideration of impact is a recent introduction from REF, but actually Richard Haldane was talking about it in 1918. From a government point of view, this also distinguishes between the specific research that's funded by individual government departments like the Department for Transport, and then general research that's funded through UKRI, EPSRC, and its other sort of sub-organisations. So I thought I'd give a few examples of the different types of activity that actually are a reality in the partnership work that we do within the Department for Transport and other agencies, whether it's other funding agencies. In some cases, we're not providing money, we're supporting work that's happening externally. But these are the stories that I tell ministers when I remind them of the importance of research and development. So a really great example is OZEV, our Office for Zero Emission Vehicles. This supported some early stage research and development that helped to understand the technology for the world's first purpose-built electric taxi through Emerald Automotive that was subsequently bought by Geely. They then invested in the low emission vehicles plants in Coventry, and as a result of that, policy changed within London that meant that electric vehicles were much more viable as an economic proposition for those who were driving taxis in London. So you have a really nice story of research and development that brings technology through and encourages economic investment in the UK, creating jobs and creating prosperity, but also an understanding of the role of policy. So that policy change in London stimulated and gave the confidence to the external world to make that investment. And that's often something that we think about a lot. ZeroAvia, a completely different company that are looking at hydrogen fuel cells for aircraft, were encouraged to be based in the UK because of government incentives and particularly the presence and the activity of Innovate UK. And then we've got things that might be maybe closer to the type of work that happens within PETRAS. So Lens Labs, 3 Edinburgh graduates in 2019 secured a very small £30,000 grant through our programme Transport Research and Innovation grants. This was to prove a new magnetic traction concept in rail to overcome something we're all familiar with, the impact of leaves and snow. They were then funded by a further larger scale proposal through our first of a kind competition, and have recently closed a £1 million seed funding round. So it's a slightly different way of thinking about research in a government setting compared to that which we've had within academia. So I just want to talk very briefly about a couple of sort of contexts and how this all works. So it is about seeing the big picture. It's about seeing that we might as a department have recommendations for where we need innovation. We also will work with industry to understand where the opportunities are and work with academia to understand where our strengths of understandings are. But what we're really steering is articulation of the problems that we need to be solved. We then can evaluate the impact and the success of the funding that we've delivered through whether we've delivered the outcomes of the research. So that might be cheaper achievement of our goals, faster achievement of our goals, more effective achievement of our goals, but also creation of jobs, companies and exports. I thought it was helpful just to bring the context back to the security context. And again, none of this will be particularly surprising to you, I hope. But there are a number of things that we need to consider when we're thinking about what our requirements are in the world of security when it comes to transport. So one of the things that's really, really challenging in the world of transport is that there are risks everywhere. And so thinking about how we can appropriately be responsive and agile to respond to changes in different types of threats and risks. An example is the increased use of digital technology in delivery of transport that exposes us much more to cybersecurity risks, for example. Thinking about how we can work effectively with other parts of the academic sector and other industries to understand how what we're doing aligns with requirements and opportunities in other parts of industry. Thinking about the differences between our different transport systems. It's very different if we're thinking about a new system we're designing as opposed to introducing technology on a legacy system. Thinking about how we communicate with our stakeholders and explain and understand the different risks we hold. And number 6, really important, keeping security measures proportionate, something we need to consider in all contexts. We need to make sure people are safe and secure, but also able to take journeys in a timely manner. A really good example here is thinking about speed of getting through airport security, for example. And there's just always a balance that we need to achieve there. So I thought I'd end with just a sort of why we need PETRAS. And I've just jumped to, I can leave this slide on while I sort of take questions. We're seeing a rapid pace of change in transport. We're seeing a change from a physical system to a digital system. We desperately need skilled people to work in transport. Transport doesn't often occur to people as an industry that they would be engaging with, and we need to lure people into the excitement of transport and mobility. There are lots of cross-government strategies, such as the AI strategy, connected and automated mobility, that we're engaging with. And we're a really complex system. And so any of the technology and the socio-technical support that organisations and consortia like PETRAS provide to us is really, really welcome. So I hope that was a helpful sort of framing, and I'm happy to take any questions.